right, topic 2 is rate of change. What does that mean? Well, we deal with rate of change every day. Examples, miles per gallon, okay? Exercise time versus calories burned, okay? Or steps versus calorie burn for those that count their steps. Hours worked to wages earned, so it's kind of your wages per hour. Study time to test score. We've talked about, the more study time you have, the better your test score is. Can you come up with some examples of rate of change? I'm going to give you one common one, miles per hour. Okay, miles per hour. You see it every day on signs on the side of the road, miles per hour. So what I want you to do is come up with an example. We'll discuss this more in class. Come up with an example to share tomorrow in class. Okay, and let's go on to slide 2. Okay, slide 2. Todd had 5 gallons of gasoline in his motorbike. After driving 100 miles, he had 3 gallons left. The graph at the right shows Todd's situation. So find the slope, rate of change. Absolutely, a slope is another name for a rate of change. If you're looking at a graph, the slope gives you the rate of change. Okay, so finding the slope of this line, we go from 5 down to this point right here, or to right there, go down 1 over 50. Okay, so if you recall slope from previous years, -1 over 50. Now, rate of change we talk about in per 1 unit. So first of all, if you look at -1 over 50, -1 dealt with gallons, and 50 dealt with miles. Okay, so that is gallons per mile. A little weird to talk about it that way, but that's how the graph is given. So if you do 1 divided by 50, we're talking about -0.02 gallons per mile. So anytime you're doing a rate of change, you want to get it down to per 1 unit. So you do want to divide that out. Okay, now what does that slope tell us? It's negative, so there's a decrease of 0.02 gallons for each mile driven. My pen isn't working that great. Each mile driven. Okay, what is Todd's miles per gallon? We're just going to flip that around. -50 over 1, or 50 miles per gallon. All right. Hopefully that makes sense, but let's go on to the next page and do another example. All right, rates of change for 1950 to 1975 and for 2000 to 2025. So let's look at 1950. In 1950, the population growth in China was 0.55. Or the population in China was 0.55, and this is talking about billion, so 0.55 billion. And 1975, the population was 0.93 billion. Okay, so the rate of change, we're going to talk about how much it changed. What is the difference here? 0.93 minus 0.55 gives us 0.38, and that was over a span of 25 years. So 0.38 billion people over 25 years. You need to divide that out. When we divide that out, you get, I'm going to write it up here, 0.0152 billion people per year. Okay, billion people per year. Now, then between 2000 and 2025, in 2000, population was 1.27 billion. And in 2025, the population was 1.45 billion. So that rate of change, well, if we look at how much did it change, 1.45 minus 1.27, that is 0.18 over a span of 25 years. So when you divide that out, you get 0.0072 billion people per year. Okay, explain the meaning of the rate of change in each case. Well, it is just talking about the increase, because it's positive, increase in billions of people increase in billions of people per year. So that's how much each year over those time frames, how much the increase in population was. Okay, increase in 14 billion people per year. This looks so messy. My pen's not working that great today, that's why. Sorry. All right, how are the different rates of change shown on the graph? Well, here, right here, 1950 to 1975, the rate of change was 0.0152, where over here, the rate of change is 0.0072. So the greater the rate of change, what do you notice about these graphs? It's steeper there, right? Than here, it's a little less steep there. So the greater the rate of change, the steeper the graph. Okay? The greater the rate of change, the steeper the graph. All right? So there's 2 more problems on the next page for you to try. Go from there, and then we'll discuss all these again tomorrow in class.